actually valid. We already have seen that there's a few metadata mismatches. So let's see how the application deals with it. Firstly, I have SQL Server right here. SQL Server, I define my source as SQL Server. I go to query and I define my corresponding DIM customer right here. Again, I did this by just dragging and dropping this corresponding table, but I can also use Query Builder to define the same. In the results window, I can see a typical sample, the schemas of the particular rows, and also how many partitions and how many rows are loaded. The throughput is actually something that works really good if you have a high transfer JDBC connection as well. But again, that is dependent on your connection itself. In a similar vein, we pick up the same file except from Snowflake. Here we see, yes, Snowflake is present right here. And within the query, we see that the order of the columns is slightly different, but it's more or less the same. And we do know that there are a few columns missing. And so in the results, we see that, okay, there is a few records missing as well, but this doesn't give the whole picture. For the whole picture, we actually go to the data compare node. Data compare node is our base node for validating data sets. What this particular node does is that it takes the entire data set and compares it against the other. It checks for duplicates, it checks for missing records from one against the other, and it has a plethora of user-related options that you can define. These include automatic data type conversion, enabling trim, and considering null and empty spaces the same. If duplicates exist, we do not want that test case to fail in other aspects, and also define the specific differences. And that's what you see right here. Additionally, there are thresholding options as well. This is particularly important when you're working with numerics and float values, where you might imagine because of some rounding, you are expecting some slight differences, and you don't want a test case to be mapped as failure because of those reasons. So the application has automatically mapped this particular set of columns for us, as you might see right here. All these columns have been automatically mapped, and here, based on the fuzzy logic itself, it's mapped. And as you can see, there is a few data type mismatch changes, and we have also defined our primary key as our customer key. This is important if we want to ensure that we can check some records one against the other. We need one column that can be defined, one or more columns that can be defined as the anchor or the joining key in SQL words, or against which we are going to see if there are any results mismatches. And finally, because we did know that the corresponding yearly income was a different data type, the application converts them both to long right here. And now let's look at the results. See, the results have already run this, and I see that, okay, there's about a 90% or a 99% match in Snowflake. This implies that most of the records that have been transferred into Snowflake are a full-fledged match. That's pretty good. And there's a few mismatches as well. If I go to mismatched, I can see the exact issues that I've seen within my data sets. And for a much closer look, I can actually go into column-wise mismatch and see the exact problem childs and exact places and columns which are causing specific problems within my data set. So here, if I would like to work with this, say I want to push these particular data sets back, I want to reconcile them. These are not just for show. These are complete data sets that I can pull and use again. So here I'll drag and drop SQL for now, and I'll drag and drop differences. And what basically this picks up is the difference data set that we have right here between our two distinct data sets. Of course, I can pick up the other aspects as well, and moving ahead, the place where we go a bit beyond, not just validating full data compare, we also check where records are absent. We see that there are records present only in dataset A, which is SQL Server. And this could have a lot of implications. And the most important implication here implies that there's been a problem within our transfer. Either new records have been flooded into the SQL Server, or the batch specific migration process that we were using has failed at some points, resulting in these set of records which are only present in SQL Server but are not present in Snowflake. And of course, if there are any duplicates and other aspects found on our primary key or keys, that would also have been counted right here. And depending on whether we wanted to fail our particular test results, the test case would have failed on that particular reason. So that is a test case of migration validation.
For further questions, feel free to reach contact@datagaps.com. Request a free demo, scan the QR code below. Thank you.